climate change and also climate science research activities, needs, and products, as the letter of invitation requested. But given the emphasis in some of the opening comments on the emails, I'm going to divert from that program and say a few words about the emails, and then finish with the concluding part of my original oral statement. The emails are mainly about a controversy over a particular data set and the ways a particular small group of scientists have interpreted and displayed that data set. It's important to understand that these kinds of controversies and even accusations of bias and improper manipulation are not all that uncommon in science, in all branches of science. The strength of science is that these kinds of controversies get sorted out over time as to who is wrong, who is right, and how much it matters by the process of peer review and continued critical scrutiny by the knowledgeable community of scientists. Of course, openness in sharing of data and methods is very important to this process. And as I think you all know, this administration is a strong proponent of openness in science and in government. And Administrator Lubchenco will have some things to say about public access to the climate data maintained by her agency and maintained by other agencies in the United States. In this particular case, the data set in question and the way it was interpreted and presented by these particular scientists constitute a very small part of the immense body of data and analysis on which our understanding of the issue of climate change rests. The question being addressed by these data was, have there been natural periods of warming in the past, in the last 1,000 or 2,000 years in particular, that have been stronger than the episode now being experienced? That's an interesting question. And because of the controversy around it at the time most of these emails were written, that is, in the early 2000s, the National Academy of Sciences undertook a thorough review of all of the relevant data sets and all of the methods of analysis, not just the data set used by these particular authors or the methods used by these particular authors. The National Academy's report on this matter was published in 2006, and it concluded that the preponderance of available evidence points to the conclusion that the last 50 years have been the warmest half-century in at least the last 1,000 years, and probably much longer. There is, and there will remain after the dust settles in this current controversy, a very strong scientific consensus on the key characteristics of the problem. Global climate is changing in highly unusual ways compared to long experienced and expected natural variations. The unusual changes match what theory and models tell us would be expected to result from the very changes in the atmosphere that we know have been caused by human activities, above all burning fossil fuels and tropical deforestation. Significant impacts on human well-being from these changes in climate are already being experienced, and continuing with business as usual in the fossil fuel burning and tropical deforestation activities that are the largest contributors to these changes in the atmosphere is highly likely to lead to growth of the impacts to substantially unmanageable levels. The details in support of those propositions are in my written testimony. Let me turn to the closing part of my remarks. I've tried to indicate in the written testimony and here that we in fact know a great deal about global climate change, what its causes are, how it works, what its impacts are and are likely to become. But of course there is more to learn, and the federal government is doing a lot in support of the research needed to learn more and its translation of that research into products our society can use to better cope with climate change. But there again, we need to do more. With that said, I emphasize again that in my judgment, and that of the great majority of other scientists who have seriously studied this matter, the current state of knowledge about it, even though incomplete, as science always is, and even though controversial in some details, as science almost always is sufficient to make clear that failure to act promptly to reduce global emissions to the atmosphere of carbon dioxide and other heat-trapping substances is overwhelmingly likely to lead to changes in climate too extreme and too damaging to be adequately addressed by any adaptation measures that can be foreseen. The United States, as the largest contributor to the cumulative additions of anthropogenic, that is, human-caused greenhouse gases to the atmosphere since the beginning of the Industrial Revolution, and still today the second largest emitter after China, and is the world's largest economy and preeminent source of scientific and technological innovation, we have the obligation and the opportunity to lead the world in demonstrating that the needed emissions reductions can be achieved in ways that are affordable and consistent with continued economic growth, that create new jobs, and that bring further co-benefits in the form of reduced oil import dependence and improved air quality. President Obama is going to Copenhagen to underline that his administration is fully committed to assuming this leadership role. The administration obviously will need the support of the Congress in delivering on this promise, and I'd like to thank you, Chairman Markey, and this committee for your own leadership in this critically important domain. I thank you as well for your attention.
Thank you, Dr. Holdren, very much. Our second witness is Dr. Jane Lubchenco. Dr. Lubchenco is the Undersecretary of Commerce for Oceans and Atmosphere and the Administrator of the National Oceanic and Atmospheric Administration. She has been a distinguished scholar on these issues. She is one of the most highly cited ecologists in the world, a member of the National Academy of Sciences, and similarly a recipient of the MacArthur Fellowship, as was Dr. Holdren. We welcome you, Dr. Lubchenco. Whenever you are ready, please begin.
Thank you, Chairman Markley. Ranking Member Sensenbrenner, members of the committee, I greatly appreciate the opportunity to testify today. I appreciate your interest in the science of climate change and the spectrum of climate sciences and services needed in this country and abroad to make critical decisions for now and for the future. As President Obama said to the National Academy of Sciences, science is more essential for our prosperity, our security, our health, our environment, and our quality of life than it has ever been before. As head of NOAA, one of the nation's premier science, service, and stewardship agencies with responsibilities for both oceans and atmosphere, I strongly support a focus on science-based decision-making. Science can help inform the understanding of opportunities and challenges presented by climate change. Through sustained federal and extramural partnerships and collaborations, the nation has made very significant progress in our understanding of climate change. The core capabilities needed to understand the state of the climate and make projections about future climate and associated impacts include integrated and comprehensive observing systems on land, in the oceans, the atmosphere, and space, research into the physical system and its interconnectedness to the human, ecological, and biogeochemical systems, modeling from intra-seasonal to multi-decadal to centennial timescales, and a means to assess and communicate the climate information about current and future impacts. 3 entities, the Intergovernmental Panel on Climate Change, the IPCC, the U.S. Global Change Research Program, and the National Academy of Sciences, have all published several peer-reviewed syntheses of the latest climate science findings and associated impacts. NOAA scientists have played a significant role in all of these assessments. For example, NOAA played a lead role in the development of the U.S. GCRP's Global Climate Change Impacts in the United States report, a landmark assessment report that Dr. Holdren and I proudly announced just this last June. And NOAA scientists made up 73% of the federal authors in the IPCC's 4th assessment report for Working Group 1, the basis of the physical understanding of climate. Since the IPCC process began in the late 1980s, a wealth of global scientific information has cumulatively provided stronger and stronger evidence that the Earth is warming and that humans are primarily responsible. As stated in the Global Change Impacts 2009 report, global warming is unequivocal and is primarily human-induced. This warming can be seen in increases in global average surface air and ocean temperatures, widespread melting of snow and ice, rising sea levels, and changes in many other climate-related variables and impacts. Most of the observed increases in global temperatures since the mid-20th century are due primarily to human-induced increases in concentrations of heat-trapping greenhouse gases. When I served on the very first National Academy of Sciences study on policy implications of global warming in the 1980s, we talked about what human-induced climate change might look like at some point in the future. Today, we know that it's happening now. We are already seeing the effects of climate change on our landscapes, our neighborhoods, our farms, as well as our forests, oceans, and mountains. We are able to measure these changes through significant advances in our observing systems over the last 20 to 30 years, many of which are the result of NOAA's responsibility and innovation, and through collaborative global and national efforts to provide systematic and widespread monitoring of the climate system and associated environmental and social changes. As a result, we have a much better understanding of present and expected impacts of climate change. Widespread climate change impacts are occurring now and are expected to increase. I emphasize that climate change is not a theory. It is a documented set of observations about the world. A key element of the U.S. Global Change Research Program emphasizes the importance of multiple independent analyses and data sets to quantify uncertainties. And therefore, we have the benefit of this policy when it comes to global change analyses. The NOAA data used in the IPCC report are open and available, openly available. They are used heavily in the IPCC results of temperature change, similar to other major global data sets maintained by other U.S. agencies such as NASA, and that maintained by other countries such as the United Kingdom. So what are these data sets? What do these observations tell us about climate change? What do we know with certainty about trends to date, and what do we think is highly likely in the future? Global average sea surface temperature has risen by 1.5 degrees Fahrenheit since 1900 and is projected to rise another 2 to 11.5 degrees by 2100. The current atmospheric carbon dioxide concentration is estimated at about 385 parts per million, which is higher than the highest point in the last 800,000 years. Temperatures in the next couple of decades will be primarily determined by past emissions of greenhouse gases, but increases thereafter will be primarily determined by future emissions. Current observed global emissions of carbon dioxide emissions are beginning to exceed even the upper range of the 2007 IPCC scenarios. There is strong agreement and much evidence that with current climate change mitigation policies and related sustainable development practices, global greenhouse gas emissions will continue to grow over the next few decades. As we continue to learn more about the climate system, I would like to reiterate the importance of looking at the Earth system holistically and understanding the interconnected nature of the ocean, atmosphere, and terrestrial systems. In particular, I want to emphasize the importance of continuing our work to better understand the oceans and the potential impacts of climate change on them. I believe we've been championing the notion that we do not have but urgently need a strong focus on ecosystem-based science to inform decisions about adapting to climate change. An ecosystem-based approach also provides a broad array of possible tools for adaptation to climate change. Climate change interacts with and exacerbates other changes ranging from overfishing to nutrient pollution to invasive species and habitat destruction. Removing one or several of these stresses is likely to enhance the resilience of the system to other stresses. Equally important is the need to acknowledge that we are likely to see surprises as human actions disrupt many fundamental biogeochemical and